This video demonstrates how to graph quadratic functions from standard form f of x equals ax squared plus bx plus c. The first piece of information we need is the vertex, and there's a formula to find the vertex when we have standard form. And that formula is negative b over 2a, and then you plug in that value into your original function, to find the y value. We had the function f of x equals negative x squared plus 6x minus 7. And to find the x coordinate of the vertex, you plug in your b and a value into this function. Our b value is positive 6, and our a value is negative 1. So positive 6, negative 1. Simplify that, you end up with 3. This 3 value is the h value for your vertex. To find the k value, you plug in 3 into your original equation. Negative 3 squared plus 6 times 3 minus 7. When you calculate that value, you'll get positive 2. So then the coordinates for your vertex are 3, 2. The first pieces of information that need to go on my graph are my vertex and my axis of symmetry. My vertex is at 3, 2, that's the value that we just calculated, and our axis of symmetry is going to cut through the vertex. That's going to be a line, a vertical line at x equals 3. I'm going to need to calculate a couple more points to make a complete graph. So I'm going to plug in a few more values into my equation. The first one is going to be x equals 4. Negative 4 squared plus 6 times 4 minus 7. Calculate that value, we get 1. So the next point that goes onto my graph is 4, 1. It's over here. The axis of symmetry cuts our graph down the middle. So any point that happens on this side of the graph is going to happen on the other side of the graph. So if there's a point at 4, 1, there's going to be an identical point called the reflection point on the other side of the graph at 2, 1. They're the same distance away from the axis of symmetry. They're both 1 unit away, and they have the same y value. So again, this point over here was 4, 1, and I don't need to spend any time plugging in the value 2 because I know it's going to come out the exact same, 2, 1. I also need to plug in one more point. I'm going to choose 5. That value is going to come out to be negative 2. So my next point is going to be at 5, negative 2. My other reflection point is going to happen over here at 1, -2. They're both 2 units away from x equals 3, our axis of symmetry, and they both occur at the y value -2. Connect my points. I have my parabola. And the last thing I want you to take a look at is the way your graph opens. This graph opens down. And the reason why is the a value is -1. When your a values are negative, your graphs are going to open down. When your a values are positive, your graph is going to open up. We can also write this equation in vertex form. Vertex form is ax minus h squared plus k. Our a value is going to be the exact same as in standard form. Our a value is going to be -1. Our vertex, we calculated that. It's at +3. Since we're moving to the left, since we're moving to the right, we're going to subtract that 3. And our k value, we moved up 2 units. So there's the vertex form. F of x equals -1, parentheses x minus 3 squared plus 2. Now I would like you to pause the video and see if you can draw the graph and convert the equation to standard form for f of x equals 2x squared plus 10x plus 5. Once you have completed the example, press play to check and see if your answer matches mine. The first thing we need is the coordinates of our vertex. And we're going to use the equation -b over 2a. Plug that value into our original function afterwards. -b over 2a, -10 over 2 times 2. And again, where I'm getting those values from, here's b, +10. Here's 2, our a value. Calculate that value, you're going to get -2.5. And that's my h value, my x coordinate for my vertex. Then I'm going to plug -2.5 into my equation. The value I get here is -7.5. To write my equation in vertex form, I have my a value. My a value is the same as in standard form. The a value is 2. X. The h value, since it's -2.5, it's going to move our graph to the left, which means in vertex form, it's a positive h value. And then our k value is going to move us down 7.5 units. So there's our equation for vertex form. 2 parentheses x plus 2.5 squared, don't forget your squared, don't forget the squared, minus 7.5. I have my coordinate point for the vertex. My vertex is going to be at negative 2.5, comma negative 7. I still need a few more points to finish my graph. So I'm going to plug in negative 1 into the original equation. When I plug in negative 1, I get a value of negative 3. My next point is going to be at 1, negative 3. And then I'm also going to plug in 0. You can plug in any points that you want. It doesn't necessarily have to be the two that are right next to your vertex. My other point is going to be at 0, comma 5. My axis of symmetry is the first thing that's going to go on my graph. It's at x equals negative 2.5. Then the coordinate points for my vertex, negative 2.5, negative 7. 1, negative 3. One negative 3, if I need my next point on the other side, I'm going to count however many spaces over to my axis of symmetry. So the distance between this point and this axis is 1.5 units. So then I'm going to have to count over another 1.5. So then my next point is going to be over here at 4. So again, these 2 points have to be the same distance away from the axis of symmetry. And then my next point is at 0, 5, up here. And 0, 5, that is 2.5 units away. So I'm going to have to count over another 2.5. So I'm over here at 5. So again, these points are the same distance away from the axis of symmetry. So it was 2.5 units to go from here to here, so it's got to be 2.5 units to go to here from here. It was 1.5 units to go from the axis of symmetry to our first point, so it has to be an equal 1.5 going the other way. Now that I have my 5 points, I can connect my graph. And the last thing I want you to do is take a look at your graph. Does it open up or down? This one, it opens up. And that matches our A value of positive 2.